press the bell icon on the YouTube app and never miss another update.
Hello students, I am Vijay, lecturer in mathematics, Siddhaganga Pure Science College. Today we discuss the chapter is circles. Firstly, briefly we recall what you know in 9th class. Okay, the first concept is definition of the circle. Circle means what? For that I return circle definition, what you already know. Simply I say that circle is a set of points which moves in a plane such that the distance from fixed point to any point is always a fixed constant. This is what the definition of the circle. Circle means a set of points which moves in a plane such that the distance from fixed point to any point is always a fixed constant. That means I draw here, this is our fixed point. The set of points they are move in a plane such that, suppose the distance from fixed point to this point I call it as P1, the point P1. So it is just 5 centimeter. Okay, the distance from fixed point to P1 is 5 centimeter. Same distance covered by all the points. Suppose distance from fixed point to P2 is also 5, P3 is also 5. So all the distance from fixed point is what? 5 centimeter. If you trace out all these points, this geometry we call it as what? A circle. So the distance from fixed point to any point is always a fixed constant. So that we call it as what? A circle. So simply I draw here. This is our fixed point. So the distance from fixed point to any point is always what? A fixed constant. The fixed point we call it as center of the circle. As you know, the fixed point in a circle, the fixed point we call it as center of the circle, usually denoted by O, the alphabet letter O, R, the alphabet letter C. Fixed point. The fixed point is always, we call it as what? A center. And the fixed distance we call it as what? Radius of the circle. Fixed distance in a circle, fixed distance is called what? Radius of the circle. So that we can denote it by small letter r. This is the definition of the circle. Okay, after you know the definition of the circle, some of the concepts you already know. The first concept is chord. You already know in 9th class, chord. Chord means what? Chord means, see, I draw a circle. This is our fixed point. So by seeing diagram we can expand. Chord means it is a line segment whose end points, whose end points a line segment whose end points lie on the circle, whose end points, suppose a line segment whose end points lie on the circle, this we call it as what? Chord. Or do you know? Chord means, once again I say that, chord means a line segment, simply I say the definition, a line segment whose end points lie on the circle, whose end points lie on the circle. After knowing chord, one more concept you already know, segment. Major segment, minor segment, correct na? Segment means the region bounded by the chord and an arc. The region athwa the area or the area bounded by the chord and an arc is called segment. The region covered by, simply say, the region covered by a chord and an arc. Okay, a chord and an arc. Arc means what? Okay, one more I say. Arc. Arc means a part of the circumference of a circle. This is nothing but complete circumference of circle. So this one, what I roughly draw, a part of the circumference of a circle is called arc. A part of the circumference of a circle. A part of the circumference of a circle is called an arc. This is what? Arc. So segment. Segment means the region covered by, bounded by chord and an arc is called segment. So here, so this one we call it as what? Minor segment, and this one we call it as what? Major segment. Correct na? So minor segment, major segment. If area is larger, then we say it is a major segment. If the area or region is smaller, then we say it is a minor segment. Chord over, segment is over, arc is over. Arc means a small portion, okay, a small portion of the circumference of a circle, or else a portion of the circumference of a circle, we call it as arc. In an arc, this simply, this one, A to B, this we call it as minor arc, correct? A to B we call it as A, P, B is called minor arc, and this we call it as what? Major arc. Major arc. This one minor arc and this one is called as major arc. This is one more concept. One more you know in 9th class. Chord over, segment over, sector. Very important concept. Sector means what? So I draw a circle, center. Sector means the area bounded by two radii. Plural form of radius is radii. Correct na? The area or else the region, area bounded by two radii and an arc. The area, or else this one also, the area bounded by what? Two radii and an arc is called sector. This one we call it as minor sector. Minor sector, and this one we call it as what? Major sector. Correct na? Sector, once again I explained, sector means the area or else the region bounded by two radii R1 and R2 and an arc is called sector. In also sector, if it's a small area, we call it as minor sector, and the larger area we call it as what? Major sector. This is some concept what you know in 9th class. So the 10th topic is the first concept. Okay, so 10th concept, first concept, a circle and a line. Very important concept. A circle and a line. For that, I draw 3 circles and 3 lines. This is what? PQ, center, 1 circle, the line segment PQ. Observe these 3 diagrams carefully. Circle and a line, circle and a line, circle and a line. One by one. First we explain. Observe here. Circle and a line. The line PQ does not intersect this circle. Correct na? This line PQ does not intersect the circle. That's why we call it as non-intersecting line, because it is away from the circle. It does not intersect. That's why this line we call it as what? Non-intersecting line. Clear? So the line PQ does not intersect the circle. That's why this line segment PQ we call it as non-intersecting line. So this is over. Diagram 1 is over. So diagram 2. Observe the diagram 2 carefully. The line PQ intersect the circle at what? 2 points A and B. Yes, now the line what? PQ, the line PQ intersect the circle at 2 points A and B. This we call it as secant. The line PQ intersect the circle at what? 2 points A and B. This line segment we call it as secant. In another way we say, we already discussed what? The chord. Just now I explained the chord. Chord means a line segment whose end points lie on the circle. A chord means it is a straight line whose end points lie on the circle. If the chord extends infinitely, infinitely, then that is nothing but a secant. If this is enough, then AB we call it as what? Chord. If the chord extends infinitely, then that line segment we call it as secant. So secant means a line segment intersect the circle at what? 2 points A and B. This is over. Observe, okay, second one over. Third diagram. Observe carefully. The line PQ, what? Intersect the circle at only 1 point. The point is what? A. The line what? PQ, the line PQ intersect the circle at only 1 point. Which point? The point is A. Then this we call it as tangent. This we call it as tangent. Very important concept. Almost all 10th topic under this concept, tangent. Once again I explain. A line segment PQ, define tangent. Okay, a line segment PQ intersect the circle at only one point. Then that line segment we call it as tangent. So tangent means, I written here, tangent means, because this is very important, tangent means a line segment intersect the circle at only one point. This is very important. A line segment intersect the circle at only one point, then that we call it as tangent. What we intersect that point, I written here. I written one more diagram. Here this is the line segment intersect at only one point. The point is A. I written here. So this point we call it as where the circle and the line meet. Then that point, here it is point A. This point we call it as point of contact. Once again I explain. Point of contact means a tangent meet at a point on the circle. So the line segment PQ, another way, the line segment PQ where it meets at a point, then that point we call it as what? Point of contact. So tangent, once again I explain that tangent means a line segment meet the circle at what? Only one point. Meet the circle at only one point. Then that point we call it as point of contact. Then that line segment we call it as tangent. Is it clear? Tangent. If in 3 diagram, the first diagram, line and circle do not intersect. First diagram, line and circle do not intersect. That's why we call it as non-intersecting lines. Second one, the line segment PQ intersect the circle at 2 points, A and B. What we observed, A and B, then that line segment we call it as secant. Third one is very important, a line segment PQ intersect or touch a point on the circle. Then that we call it as tangent. Then that point we call it as what? Point of contact. So we discuss some points regarding tangent by asking the questions. In the question and answer method, so we see the concept of tangent. The first question. So we discuss some more points regarding tangents in question and answer method. Okay, that is very helpful for in your examination. The first question is, how many tangents drawn from a drawn from a single point? Question number 1. How many tangents drawn from a single point? This is very important. Tangent, you know, how many tangents drawn from a single point. So for that I draw a circle and the tangent. The answer is only one tangent. Correct na? Answer is only one tangent. In a single point, how many tangents drawn from a single point? In a single point, it is possible to draw only one tangent. This is the first question, first concept. So I discuss in the question and answer method because it is very helpful for your examination. For the first question is, how many tangents drawn from a single point? Answer is only one tangent. Only one tangent drawn from a single point. First question is over. Second question. Second question, how many tangents are parallel? How many tangents are parallel on a single circle? How many tangents are parallel on a single circle? For that, so see the answer, you only tell. So I draw a circle. Center is origin. These two are the 2 points. This is one tangent, PQ. This is another tangent, RS. How many tangents are drawn? So if I draw a tangent here, one more tangent, XY. Is it XY is parallel to PQ or is it XY is parallel to RS? No, XY is not parallel to, correct, PQ. The only possible is 2 tangents. How many tangents drawn are parallel to? How many tangents are parallel on a single circle? It is only 2 tangents. Correct na? 2 tangents. The tangent PQ. The tangent PQ is parallel to tangent RS. Answer is what? 2 tangent. Answer is what? 2 tangent. One more question. How many tangents? One more question. How many tangents are parallel to secant on a circle? How many tangents are parallel to secant on a circle? So for that one, so we draw a circle first. We draw a circle. So we draw a secant. This PQ, secant. This PQ is nothing but secant. Then, so the possible tangents for parallel to PQ is first one, RS. This is a tangent, meet at a point A. No doubt, RS is parallel to what? PQ. One more tangent, XY. This meet at a point B. No doubt, XY is also parallel to PQ. The tangent RS and XY are parallel to what? PQ. So for that answer is two tangents. Correct now? Two tangents. Very important three questions. So one more questions. Next question. How many tangents drawn how many tangents drawn from a point inside the circle? How many tangents drawn from a point inside the circle? That means the point lies inside the circle. This is our circle. This is the fixed point. And this point P, it lies. The point P lies inside the circle. The question is, how many tangents drawn from a point inside the circle? Suppose I draw a line segment. Is it tangent? No. It is meet at, or else it is intersect at 2 points. It is intersect at 2 points. That's why it is not a tangent, it is a secant. Correct na? So the answer is 0. Zero tangents. How many tangents drawn from a point inside the circle is 0. Correct na? Answer is 0. Okay, inside is over. Next question. How many tangents drawn from a point on the circle? How many tangents drawn from a point on the circle? How many tangents drawn from a point? So this is fixed point, this is a point. Say it as P. How many tangents drawn from a point on the circle? This point P lies on the circle. Correct na? This point P lies on the circle. How many tangents? It is only one tangent. It is possible to draw a point P on the circle. So answer is only one tangent. Correct na? On the circle we draw only one tangent. Clear? Next question. One more questions. How many tangents drawn from a point? How many tangents drawn from a point outside the circle? drawn from a point what? Outside the circle. For that, we draw circle whose center is at O. At this point P, observe here, this point P lies what? Outside the circle. How many tangents are possible? From the point P, I draw one tangent. It meets at the point K. The tangent Px. So one more possible tangent. From the point P, I draw one more tangent that will meet at point P. So PA and PB are two tangents. So you got the answer, I think. Are the two tangents from the circle. So the point P lies outside the circle. So question is, how many tangents drawn from a point outside the circle? Answer is two tangents. Answer is two tangents. Correct na? So PA and PB are the two tangents. Here observe here, PA and PB we call it as length of the tangents. Length of the tangents. PA in the diagram, written here in the diagram, PA and PB are called length of the tangents. Very important. PA and PB are called what? Length of the what? Tangents. These are the point regarding about tangents. Okay, so next we see the next concept. The concept is theorem. Two theorems are there in this chapter. We will discuss one by one. Two theorems are there. The first theorem, statement, the tangent at a point, of a circle is perpendicular to the radius through the point of contact. See, in this chapter, two very important theorems are there. The theorem 1, the statement is the tangent at a point of a circle is perpendicular to the radius through the point of contact. So for that, observe here, I draw a circle. Okay, so this is what the center is O. So I draw a tangent x, y. This point, what I call it as a P, so we call it as point of contact. What did I discuss? Point of what? Contact. Where the tangent and the circle meets, then that point we call it as what? Point of contact. I draw a radius. sorry. So given a circle with center O, correct? A circle, what he has given? A circle with center O and a tangent xy meet the circle at P. This is given, correct? So observe here what he has given: a circle, understand, a circle with the center O, a circle with center O and a tangent xy meet the circle at a point P. Next, to prove that, what we have to prove? So the tangent at a point of contact on a circle is perpendicular to radius through the point of contact. That means OP is perpendicular to OP, written here, OP is perpendicular to what? XY, correct? OP is perpendicular to XY. For that, proof. What I do, I draw one more line segment OQ, meet at the point on the circle at M. OQ, draw one more line segment OQ. So this OQ meet the circle at a point M. Okay, so this is the construction. What we have to prove? Proof. Observe here, OQ, OM and OP are the what? Radius of the circle, correct? OP and OM are the radii of the circle. Simple method we have to prove. Okay, radii of the circle, correct? In a circle, already we discussed that according to the definition, OP is equal to what? OM. OP is equal to OM, correct? From figure, you observe very carefully, from figure, OM is less than OQ, correct now? So the length of OM is less than the length of OQ, correct? OM is less than OQ from figure. This is the next step from figure. Since OP is equal to OM, instead of OM, I written OP. That implies OP is less than OQ. Correct? OP is less than OQ. That means OP is the shortest side or shortest length in tangent xy. Correct? In the tangent xy, OP is the shortest length or shortest line segment, length or line, whatever you would say, shortest length or line in the tangent xy. That implies OP is perpendicular to xy. Sir, how can you say, sir, OP is perpendicular to XY? We are not clearly understand for that. See, observe here. OP is, proof is over. OP is perpendicular to XY. So I draw a line segment. In that I draw a point P. First draw PM. P2. Yeah. So one more line segment I draw PN. This is perpendicular. Okay. Perpendicular to what? XY. Perpendicular to XY. So one more line segment I draw PT. One more line segment I draw PR. Observe carefully. PM is less than PN. Correct na? The length of PN is less than the length of PN. As well as PM is, this one is R. PM is less than PR. Correct? The length of PM is less than PR. So this is why I call it as S. Sorry. PM is also less than PS. PM is also less than PS. If you draw one more line segment, PT, no doubt, PM is less than PT. What is the conclusion? The perpendicular line is always shortest line among other lines. The perpendicular line is always the shortest length among all other lines. Correct? By seeing this conclusion, we say that OP is shortest length among OPQ. If OP is less than OQ, that implies OP is perpendicular to XY. This is the first theorem. What it says? The first theorem says that, first theorem, very important concept. This proof is over. The first theorem says that in a circle, if you draw a tangent, this point is called as O, and this point of contact we call it as P. The OP, radius of the circle, is always perpendicular to what? XY. This is very important concept. OP is always perpendicular to what? XY. The theorem 1 is over. We will see the next theorem, theorem 2. Statement. Next theorem. The lengths of tangents drawn from an external point to a circle are equal. Very important. The length of tangents drawn from a point. The point lies on external. Outside the circle are equal. Observe here. What he has given? A circle with center O. Let P be a point lies outside the circle. PA, PB, PA, PB are the two tangents drawn from the point P. This is what? The center. Given a circle with center O and PA, PB are two tangents two tangents, correct? PA and PB are the two tangents. This is given. To prove that, what we prove that the lengths of the tangents drawn from an external point to a circle are equal. PA and PB are the lengths of tangents. So to prove that, what? PA is equal to PB. Very important. To prove that length of the tangents from PA to P to A and P to B are equal. PA is equal to PB. Construction. What we do here, join OA, OB, OP. Construction in that part, join OA, comma, OB and OP. Join OA, OB and OP. Proof. I written here. Observe the first point, what we discussed in the first theorem. These two are perpendicular. In that, PA is perpendicular to OA and one more, PB is perpendicular to what? OB. These two are by theorem 1. Just now we discussed, correct? By theorem 1. PA is perpendicular to OA, PB is perpendicular to OB. Okay. Next, observe the diagram very carefully. Here there are two triangles. One is PAO, PBO. From in a triangle PAO and triangle PBO. PAO, PBO. First one, angle OAP. Angle OAP is equal to angle OBP. Correct now? Because right angle. 90 degree or 90 degree. Correct? Angle OAP is equal to angle OBP. Second point. Observe carefully. Second point. OP is equal to OP. OP is equal to OP. Common side. Correct? Common side. Common side. OP is equal to OP. Third point. OA is equal to OB. Radii of the circle. OA is equal to OB. Radii of the circle. So observe carefully. The first one is angle. Second one is two sides. According to by RHS rule. You already know in 9th class RHS rule. Okay, according to RHS rule, I written here. According to RHS rule, the triangle PAO is congruent to the triangle PBO. The triangle PAO is congruent to the triangle PBO. That implies, according to the congruency property, CPC rule, what? PA is equal to PB. By CPCT rule, this is also you know in 9th class, according to CPCT rule, PA is equal to PB, hence proof. Understand? These two are two theorems in this chapter. Very important theorem. Second one is the length of tangent drawn from the external point is always same by CPCT rule. Means CPCT rules means what, sir? Once again I explain. CPCT rule means if two triangles, this one is ABC and X, Y, Z. If these two triangles are congruent, corresponding sides are equal. AB is equal to XY, BC is equal to YZ, AC is equal to XZ. According to CPCT rule, PA is equal to what? PB. Thank you.